What the combustion process does is it will break apart that hydrocarbon into hydrogen. Hey guys, welcome back. Hope you had a great Thanksgiving. This is Steve here from 6 Star Automotive. So I wanted to get a video done even though it was a holiday weekend. So I was thinking about the video I made last week and I thought it was about time for me to make a cat video. Before we get started, as usual, please like, subscribe, and follow me as we talk about catalytic converters. So before we talk about catalytic converters, we should probably talk about the reason that they exist. Most people know that it's part of your emission system, but very few really understand what they actually do and how they work. So I'm hoping I can shed some light on that for you today. So let's talk about the chemistry of the combustion process. So in order for an internal combustion engine to create power, it has to burn hydrocarbon in the form of fuel and oxygen, which we get from the air. So in a perfect world with perfect combustion, all the hydrocarbon would get used up in that process, and so would all the air, and we would end up with nothing more than water and carbon dioxide. Unfortunately, combustion is a rather messy process, and it doesn't always happen that way. We have partial combustion, we have misfires, we have lean conditions, we have rich conditions, and all of those prevent stoichiometry, which we'll talk about in a little bit. So like I said, our fuel is a hydrocarbon. So you have HC, and then you have O2 from oxygen. So what the combustion process does is it will break apart that hydrocarbon into hydrogen and carbon. After the combustion process, you'll have the hydrogen left over and the oxygen. They will combine to create water. That will come out the back, and then you'll have the carbon and the oxygen together, which will create CO2, and that will go out of the exhaust. The problem, though, is partial combustion, so you'll actually have hydrocarbon go directly out of the exhaust stream. You can have the hydrogen mix with just one oxygen atom and have hydrogen monoxide. That can go out the exhaust stream. And one thing to think about, our atmosphere is actually 78% nitrogen. So you really can't get that out of the combustion process, and what happens is you can end up with what's called oxides of nitrogen. We'll talk about that in just a second. So I'm going to go into a fair amount of detail in this video, but these guys on NewMind did an excellent video on this subject. Their production value and their team is a lot more advanced than just me. So what does nitrogen mean in the exhaust system? So when you get above 2,000 degrees, nitrogen will actually combine with oxygen, and they call it NOx. X actually is a stand-in, so you can have NO1, NO2, NO3, and they just group those together in what they call NOx, or NOx. Oxides of nitrogen are very bad for the atmosphere, they're bad for ozone, they're bad for us, they're highly toxic, and something we really don't want to come out of the vehicles. So what do we do with all this? What do we do with all this chemistry and all these pollutants that are coming out of the back of the cars? Before the 60s, we really didn't do anything. We just let whatever happened happen, and we didn't really deal with it. And there was a connection that was made with internal combustion engines with the type of what they called smog around the big cities. So in comes the catalytic converter. This thing is a piece of engineering that is just astonishing with how simple it is and how well it actually does its job. It just is a godsend. A lot of people may hear catalytic converter and just cringe because of how expensive they are, and I can explain to you why that is. So catalytic converters are made out of 4 very precious metals. We have platinum, palladium, rhodium, and cerium. The inside of a catalytic converter houses a ceramic substructure that is coated in these very precious metals that we talked about. It's about 3 to 7 grams each. And if you add up the value of all those metals, it ends up being about what the catalytic converter costs. Some guys way smarter than me found out that when you get platinum, palladium, rhodium, and cerium up to a certain temperature, about 800 degrees or so, they oxidize the gases around them. So after a few iterations of design, they came up with what they have now, which is a modern honeycomb-like structure that has very, very high surface area and allows for very even and smooth flow through the catalyst that actually only reduces horsepower by about 1% for the amount of emissions that it saves. It's not a very big compromise. One really important thing to note is that catalytic converters are surrounded in a blanket of vermiculite. That vermiculite is an amazing compound, but when it gets hot, it expands. If you ever have a catalytic converter replaced, you have to do a break-in procedure, and it will expand that vermiculite and lock that catalytic converter in place. That has to happen, or there's a high likelihood that that catalyst will fail early. So inside of a catalytic converter, there are 2 what they call beds. There's a reduction bed and an oxidation bed. The reduction bed kind of does what it sounds like. It actually breaks molecules apart into their specific atoms. So carbon monoxide becomes carbon and oxygen, hydrocarbon becomes hydrogen and carbon, and so on and so on. So the reduction layer breaks molecules apart. So what does the oxidation layer do? The oxidation layer adds oxygen to those broken apart molecules to create the ones that are less dangerous. So it takes the carbon, adds 2 oxygens, creates carbon dioxide. It takes the hydrogen atom and another hydrogen atom with an oxygen atom in order to make water, H2O. And it takes the NOx, the oxides of nitrogen, pulls the nitrogen and the oxygen apart, holds the oxygen together, letting the nitrogen on its own pass, and then uses that oxygen that it pulled out of the NOx to oxidize the other atoms. So this process is so efficient that it actually can have vehicles get as low as 0 emissions at times. One of the only caveats in this situation is that the reduction bed and the oxidation bed have to function slightly differently. The reduction bed works better in a slightly rich mixture, and the oxidation bed requires a slightly lean mixture in order to function. So like I said earlier, stoichiometry. So stoichiometry is best explained with something I think that everybody understands. If you take your vinegar and your baking soda, right? So if you have stoichiometry, the perfect amount of vinegar and baking soda would end up combining, and all of the vinegar and all the baking soda would be used up in that process, and there would be no more reaction. If it were too rich or too lean, right, so more or less of one or the other, you're going to end up with vinegar left over or with baking soda left over. So stoichiometry is that relation between the two compounds that means that that reaction would reach 100%. So in vehicles, that stoichiometric ratio is 14.7 parts of air to 1 part of fuel. So vehicles will generally run between 14.6 to 1 and 14.8 to 1. In order for vehicles to do this, they need what's called an oxygen sensor. So the oxygen sensor tells the computer how rich or lean the air-fuel ratio is. It uses that to go back and forth between rich and lean in order to keep the reduction bed and the oxidation bed working as efficiently as possible. Modern OBD2 systems also will have oxygen sensor before the catalyst and an oxygen sensor in the back of the catalyst. So the one before the catalyst is going to let the computer know what the air-fuel ratio is and how it should go rich, lean in order to make the system to function ideally. And the downstream sensor is a monitor for that catalyst itself. If that rich and lean signal match, then the catalyst inside cannot be working. But if the downstream stays solid and the upstream goes up and down like it's supposed to, then it knows the cat is functioning. So one of the main reasons I wanted to make this video is to get you guys to really understand what the catalyst does and what it is. A lot of people get that catalytic converter code and they'll think, no big deal, whatever. But if you think about it, I mean, if everybody didn't have a catalytic converter, we already see where we would have been, right? So it is important to make sure that you have that catalyst working as much as is absolutely possible. I know you've been behind a car that was made in the 1960s and what that smells like. Imagine if all the cars still did that. So that's my video on one of the most historic technologies ever made. If you have any questions, go ahead and leave them in the comments. Don't forget to like and subscribe, and come on by to experience a 6-star difference for yourself. So in order for an internal combustion,